All right. So good morning, everyone. Again. So good morning, Jasmine, Kenny, Levana, Shayona, and Sylvia. So for this week, our topic is all about decomposition, oxidation, and reduction. So last Monday or last Tuesday, I asked you to study the Quizlet set. Okay, so the Quizlet set has the all the terms that you need to remember and you need to learn for this topic about decomposition, oxidation, and reduction. So before we move on to our lesson, let us first define what decomposition, what oxidation, and what reduction is. Okay, so for Jasmine, okay, can you tell the class what decomposition is? Jasmine. Hello, Jasmine. You can message in the group chat if you don't have your audio, or whoever. Okay, how about Levana, Shayona, Sylvia? What is decomposition?
Should I answer?
Yes. Okay, Shayona.
Okay, I think decomposition is when you're breaking down like a molecule to when you're breaking it down to its
Okay.
elemental form, right?
Okay, all right. Okay, yes. Okay, so that's correct. So from the word decompose, okay, when you say decomposition, you are breaking down compounds, okay, you are breaking down the molecules into its simple product, or it could be in its an elemental form. Okay, so you mentioned about elemental form. Anyone here? Okay, no problem, Jasmine. It's fine. Anyway, going back, elemental form. So Shayona mentioned about elemental form. What is this elemental form? Elemental form is, so basically it's the the form of the element, the simplest form of that element. For example, for oxygen, the oxygen is the elemental form, or the O2, right? So the simplest form of the element. How about oxidation? Okay, Levana, what have you learned about oxidation?
Wait. It's a chemical change in which a substance combines with oxygen.
Okay, so when you say oxidation,
and then it
from the word
forms rusts.
Okay, so yes, that's correct, Levana. Okay, so from the word oxide, from the word oxygen. So when you say oxidation, this is also a chemical process. This is a chemical change in which a substance combines with oxygen. For example, you have your iron, okay, which is a metal. Your iron, once it combines with oxygen, okay, it will oxidize. It will form rust. Okay, rusting is a form of oxidation reaction. Okay, so the iron plus oxygen will form your rust. Okay, so again, that's an example of oxidation reaction. Also combustion. Okay, so combustion is an example of oxidation. Now, how about reduction? So decomposition, it's changing, okay, chemical reaction that breaks down the compounds into its simpler product or simpler products. And oxidation is a combination of oxygen. Uh, it's a chemical reaction where a substance is combined with oxygen. Okay, and that, again, an example is rusting. And how about reduction? Okay, reduction is, Sylvia, what do we mean when we say reduction? Sylvia?
Oh, sorry, it's lagging.
Okay,
Reduction
yeah.
means gain of
Okay, so reduction is gaining of electrons. So once a compound or molecule gain electron, it is called a reduction reaction. Okay, now let's move on to this image here. So this image here shows the different times, okay, where or when the metals are discovered. Okay, so these are the times when the metals were discovered. So in 9000 BCE, or this is before the Common Era. So the earliest objects of native copper were discovered in the Middle East. So as you look at the first few years here, most of the metals are discovered or are extracted in Middle East. Okay, so in 5000 to 3000 BCE, the melting of copper from ores in Middle East, and also in 3000 to 1500 BCE, it's the Bronze Age. Okay, copper and tin alloys in Middle East as well. And in 2500 BCE, the gold and silver objects were also found or extracted in the Middle East. Okay, so as you notice here, there is the Bronze Age, Iron Age. What, or how do you think? Okay, how do you think scientists, or how do you think those people from those people came up with these names? Okay, with this Bronze Age, with this Iron Age, how do you think they come up with this names? Okay, to name the era, or to name that generation. Kenny. Hello, Kenny.
Yeah.
Yeah, how do you think they come up with metal age, or sorry, Iron Age, Bronze Age?
I think it's by like when they discovered that thing like Iron Age, they discovered iron.
Okay, all right. So throughout the ages, okay, this years, okay, they were organized by the time of their discovery. Okay, so Kenny was right. So for example, during that time, it's the Iron Age, because during that time iron or irons were discovered. Okay, and during the Bronze Age, most of the bronze metals, they were discovered or extracted during that time. Okay, now, question, why do you think some metals were used earlier than others? Why do you think here, as you can see here in the image here, or the chart here, okay, why do you think some metals were used earlier than others? Jasmine.
I don't know.
Okay, all right. So if you read the book, okay, so it says there that some metals, they were obvious to our ancestors. Okay, why is it obvious? Because some of this are in its elemental form. They are pure in elemental form in the ground. So it means that they are easily extracted. They are accessible to our ancestors. And we call this elements native deposits. Okay. So again, native deposits, these are metals that are found in its pure elemental form in the ground. Okay. And you will easily identify it using the reactivity series here. So as you can see in this reactivity series, all the metals that are lower than hydrogen in the reactivity series, they are native deposits. So here in this reactivity series, can you name the four metals that are native deposits? Levana, what are um, four metals here that are native deposits?
Copper, silver, gold, and platinum.
Okay, very good. So here, as you can see, this is hydrogen here. Okay, all the metals that are lower than hydrogen, they are native deposits. Okay, as you can see here, copper, they found gold, silver, okay, because they are easily accessible. They are found in its elemental form. So um, it's easy for them to extract these metals. So for example, the gold, okay, which is quite often found in small particles or nuggets in rivers, since groundwater washes it out of the surrounding earth and down river. So it's easy for them to find this gold. So they discovered this earlier than the other metals. So that's the reason why some metals are found earlier than the others. Okay. Now, many metals are found in compounds they form with other substances as ores. Okay. What are these ores? Ores are minerals that are mined because they contain useful metals or non-metals. So we have here four examples of ores. Okay. We have bauxite, hematite, malachite, and galena. Okay. So bauxite is an aluminum ore. So it means that aluminum are extracted from bauxite. Okay. The bauxite is the world's main source of aluminum, and it consists mostly of the minerals um, like gibbsite, baumite, and diaspore mixed with the two iron oxides. Okay, so that is your bauxite. Again, this is the aluminum ore. Okay, kindly remember that. Next is your hematite. Hematite is an iron ore. So it means that irons are extracted from hematite, or can be extracted from hematite. Okay, hematite is a reddish black mineral consisting of ferric oxide. So from the word ferric, ferrous, ferrum, iron is extracted from this. Okay, and here you can see the greenish mineral. This is used as an ore for copper. So malachite is where we extract copper, and sometimes it's used for making ornamental objects. Okay, so again, ores are used to extract metals. So we extract copper, we extract iron, we extract aluminum from these ores. And lastly, we also have the galena, which is where we extract the lead. Okay, so it's a bluish gray or black mineral of metallic appearance, and it consists of lead sulfide. So it has lead sulfide, and we extract lead from this ore. Okay, so these are the ores. These are uh, we use these metals, and we extract this this from this ores or metal ores. Okay, we extract this metals from this metal ores. Now, another question is, how do we exploit properties of chemicals? Now, how do we use this? How do we extract? How do we get um, this metals? Now, earlier during the Industrial Revolution in Europe, they depended on scientific discoveries about the properties of metals. And one very important metal, both then and now, is iron. Okay, so we know that we use iron in construction, nails, okay, This is an important iron is an important metal for industries, especially during the Industrial Revolution in Europe. So iron, it was first extracted and smelted in 1709. When you say smelting or smelted, smelting, this is the process of heating, extracting metal from its ore by process involving heating or melting. Okay, so when you say smelting of iron, it means we extract iron from its ore by heating or by melting. Okay, so that's smelting. So if we talk about tin smelting, so it means extraction of tin from its ore by heating or by melting. So that is what smelting is. So in 1709, iron was first extracted and smelted, and it was used as a construction material in its elemental form. Okay, so again, a while ago, Shayona mentioned about elemental form. This is the simplest form of an element. Okay, in 1740, it was combined with small quantities of carbon as an alloy to form steel. So in 1709, it was discovered, it was extracted, iron was extracted, and then in 1740, it was combined with small quantities. Iron was combined with carbon to form alloy. Okay, now alloy is a combination or a mixture of two or more metals. So alloy here, we combine carbon and we combine iron to form steel. Okay, iron ores are forms of iron oxide. Again, we can get it from, or we can extract it from hematite, right? And iron is extracted from its ore in a blast furnace, which uses very high temperatures, and carbon in the form of a fuel called coke. Okay, coke here is not your Coca-Cola. Okay, coke here is later I will show you a video about the blast furnace in order for us to get to know more about this. Okay, so they use this fuel, they call it the coke, to remove the oxygen from the iron ore. Okay, so let's take a, okay, so I'm gonna show you how iron ore was extracted. All right, so here, let's learn from the iron ore. Okay, can you tell me if you can hear the sound? All right. Can you hear the sound?
No.
Yes. All right, so this is the blast furnace. Okay. Oh, sorry. Wait. Okay. I'm gonna stop sharing this, and I'm gonna share this screen. All right. Okay, can you see the video?
Yes.
Yes.
All right. Can you hear the video?
Yes.
Okay. So this is all about blast furnace.
Teacher, we can't hear the sound.
Okay, all right. All right, so I'll check the sound. Okay, audio settings. All right. Uh-huh. So let me check. All right. So I will just be explaining. Okay, so this is all right. So the blast furnace here, it's a large steel structured lined with refractory fire bricks that can withstand temperatures approaching 2000 degrees Celsius. Now, this blast furnace, it was first used in China during the Han Dynasty. Okay. However, it was in 1709 that Abraham Darby, so he was the one who developed a blast furnace that could be fired by coke instead of charcoal, which paved the way for modern day blast furnace. Okay. So as you can see here, let me go back here in this. Okay, so as you can see here, here, okay, so these are fire bricks that can withstand temperature, okay? Here, it's very hot here. So as you can see, metals are put here in the blast furnace. All right. All right. So again, here, this steel here is derived from an iron ore. Okay. So again, an example of an iron ore is your hematite. So steel here is a combination of carbon and iron. Okay. Steel is an alloy, a combination of metals. So here, so the principle involved here means in this means of extracting metal is the reduction of the ores by the action of the carbon monoxide. Okay, that is the removal of oxygen from the metal oxide in order to obtain the metal. So we remove oxygen from the metal oxide in order to obtain the metal. So here you can see, all right. So what did you notice here? Okay, so let's go back. So here we have two iron atoms and three oxygen atoms here. Here we have three carbon and three oxygen atoms, right? So what happens is, okay, so what happens is there is a reduction, okay? So here, the iron here, 2 irons here are left, and then this 3 carbon and 3 oxygen atoms here. So the compound here, your 3CO became 3CO2, okay? So again, going back, okay, so again, from here, so this is your carbon monoxide. So there are 3 carbon monoxide atoms or carbon monoxide molecules here, and your ferric oxide here. Okay, so this is your ferric oxide, and this is your carbon monoxide, and then there is this is your iron ore. Okay, and what happens is there is a reduction of the ore by the action of your carbon monoxide. So again, this is your iron ore, your ferric oxide. So ferric oxide, it reduces. Okay, so the chemical reaction is reduction because the 3 oxygen atoms, or the 3 oxygen atoms are removed from the metal oxide, okay, in order to obtain the metal. Okay. So see here, because of the reduction, what was left was your iron. Okay, so this is what the elemental form is. So that is your reduction reaction. So again, here we use carbon monoxide. So because of the carbon monoxide, it removes the oxygen. It removes the oxygen from your ferric oxide. Okay, and now what was left is your elemental form, which is the iron. All right. So this, it is lined with fire bricks here. So the blast furnace, it is lined with fire bricks. Okay. So as you can see, it increases in diameter going down. Okay, it's increasing, and then it's decreasing again. All right. Okay, so this is where the fine molten products are heated. All right. So the furnace is fed from the top, which has an entry referred to as the charging hole, with a charge of definite quantities of ore, coke, and flux, consisting mostly of limestone that is carried over the charging ramp. Okay, so again, limestones, these are sedimentary rock consisting mainly of calcium that was deposited by the remains of marine animals. Okay. All right, so this is how it works. So that's the charging hole. All right. And then this is the charging ramp. This is water. Okay, so this is your water wheel. So this acts like a turbine. And then here, okay. So
Teacher, I
there
didn't
is a
quite understand how the
preheated
process
compressed air here.
works. Could you please repeat it?
Sorry? Yeah.
Teacher, I didn't
Yes,
quite
again.
understand the process. Could you please re-explain it? Yeah,
All right.
thank you.
What we only need to know here actually is the how the reduction happens. Okay, so here we just what I'm showing you is I just wanted to show you this blast furnace. Okay, what this blast furnace looks like and what does it do. Okay, so again, the blast furnace, it was developed by Abraham Darby, and it uses coke instead of charcoal, uh, which help, okay, in producing or in extracting the iron from its iron ore. Okay, so what happens is they use, okay, so they use the metal ores, okay, here, and heated the metal ores. All right, sorry, here. So it's melting, okay, it's smelting the iron using this blast furnace. So what happens, what you need to know is how this one happens. So this is again a reduction reaction. Okay, why? Because this again, from its metal ore here, which is ferric oxide, it will be reduced into its elemental form. Okay, so that's the principle behind this blast furnace. All right. So the process of the blast furnace here, okay, you don't really need to know or understand. What you need, what I just want to show you is this blast furnace here and what happens with the metal ores. Okay, so for the metal ores, this is what happened from the ferric oxide here. Can you see the ferric oxide? The ferric oxide here, it will be reduced using a carbon monoxide here. This is your carbon monoxide here, and this is your ferric oxide here.
Teacher,
okay?
in all
Yes.
of these processes, is carbon monoxide always needed?
For this one, okay, for in using blast furnace and in extracting iron from iron oxide, they use carbon monoxide. So carbon monoxide can be used, okay, or they use carbon monoxide for
okay.
this.
Thank you.
All right. So in using blast furnace, so the coke first burns to form a gas called carbon monoxide. Okay. So like here, under here, so the coke first burns to form the carbon monoxide. So they are burning the carbon monoxide, or they are burning the coke to form carbon monoxide. Okay, so that they can extract ferric oxide, that they can extract iron from the ferric oxide. So what they put here inside the blast surface is your ferric oxide, or what they put here is the metal ore. Okay, so they put the metal ore here. Here they burn the coke in order to form your carbon monoxide, because they need the carbon monoxide for this reaction. Okay. All right. Did you get it?
Yes.
So again, they burn. Okay, so they burn the coke. Okay, they burn the coke here, and then they put the metal ore here. So they burn the metal ore, and then what happens is this reaction. The carbon monoxide. Sorry, not that one. Okay, the carbon monoxide here. So 3 carbon monoxide molecules and your ferric oxide here. Once it reacts with each other, okay, what happens is this oxygen atoms will be removed, okay, leaving the iron in its elemental form. Okay, so here again, if you look at the furnace here at the back, so this is the metal ore, and then they burn the coke to form the carbon monoxide. So carbon plus oxygen here, the one that happens here under, okay, we call this combustion. Okay, why is it called combustion? Because you have your carbon plus your oxygen will form your carbon monoxide. So it involves the addition of oxygen to a material. And again, that is an example of oxidation reaction. So this one is combustion. Okay, this combustion here, so they uh, burn, okay, the coke to form carbon monoxide. Okay, this reaction here, we call it combustion. Combustion is another example of oxidation reaction. So iron rusting is an example of oxidation because iron, when it reacts with oxygen, it will form rust. Okay, so that is an oxidation reaction. Combustion also is an oxidation reaction because here carbon is reacting with oxygen to form carbon monoxide. All right. But what happens here, okay, what happens here is a reduction reaction. So it is reduced, okay? Your ferric oxide is reduced to form iron in its elemental form. All right. So that those are the principles, okay, behind your reduction, your oxidation, and yeah. So that's how we exploit the properties of chemicals. That's how we extract. Okay, that's how we smelt the iron. All right. So they understand the decomposition or reduction and oxidation.
Yeah, thank you.
All right. Okay. And all right. So I'm gonna make this. All right. Okay. So to review. Okay. All right. So for us to review what we have learned today, I want you to get your, I want you to open your Kahoot, or you can go to www.kahoot.it. Right. Let's check. Let's check this one. All right, and let's have a review. So kindly go to 507, or kindly key in 5071050. You can go to www.kahoot.it, or you can open your Kahoot app. Okay, so this is just a recap, a review of what we discussed this morning. All right, where are All right, so let's start. For those who are here, just okay. So Livana's here. Okay, Jasmine, Kenny.
Teacher, it's still loading.
Okay, so for those who haven't joined yet, okay, so you can just listen as well. Okay, try answering the questions so that we can start. All right. Okay, let's see. Okay. All right, so question number 1. Mercury were used for gilding during the Roman Empire in which year? Again, mercury were used for gilding during the Roman Empire in which year? Is it 1500 BCE? Is it 600 BCE? 200 to 300 Common Era? Or 1200 to 1450? Again, mercury were used for gilding during the Roman Empire in which year? Okay, so the correct answer is 200 to 300 Common Era. Okay. Okay, question number 2. What happened in 1826 in France?
Teacher,
Yes.
something is wrong with my Kahoot. I think something is wrong with my Kahoot. Oh, okay, never mind.
All right. So just try answering. Okay.
I think it's working now.
What happened in 1826?
What's
in
the
France?
second question?
Okay, so zinc used for statues. Okay, you have to open your Zoom because the questions are in Zoom. Okay, the video, right? So what happened in 1826 in France? Zinc was used for statues. Okay, so these are in the chart. All right, let's see. Question number 3. In 600 BCE, cast iron were smelted from its ore in which country? Is it China? Is it Middle East? Is it England? Or is it France? Again, in 600 BCE, cast iron were smelted from its ores in which country? Is it China? Is it Middle East? Is it England? Or is it France? Okay, so the answer is China. Okay, remember in the video I showed you a while ago, they started smelting iron or cast iron in China. So it was in 600 BCE. But then Abraham Darby, he used the blast furnace to extract or smelt iron from from iron ore. Okay, in 1709, right? So that leads us to the next question. Which of the following are examples of native deposits? Is it potassium? Is it magnesium? Is it platinum? Or is it iron? Okay. All right, so the correct answer is platinum, right? So platinum is a native deposit. Those metals that are lower than hydrogen. Another example is your copper, silver, and gold, right? These are minerals that are mined because they contain useful metals or non-metals. Again, these are minerals that are mined because they contain useful metals or non-metals. Okay, that correct answer is ores. Okay, so minerals that are mined because they contain useful metals or non-metals, that we call it ores. All right. Okay, question number 6. An iron ore. Is it bauxite, hematite, malachite, or galena? Again, an iron ore. Is it bauxite, hematite, malachite, or galena? Okay, the correct answer is hematite, right? So again, it contains ferric oxide, and once it is combined or reacted with your carbon monoxide, it will produce iron in its elemental form. Okay, we call it hematite. That is an example of an iron ore. Okay, and Shayon is now leading. Question number 7. A copper ore. Is it bauxite? Is it hematite? Is it malachite? Or is it galena? Okay, so the correct answer is malachite. Okay, so the green one. It is also used as an ornament or ornamental object. All right. Question number 8. It was first extracted in 1709 and used as a construction material in its elemental form: gold, iron, carbon, or lead. It was first extracted in 1709 and used as a construction material in its elemental form. Is it gold, iron, carbon, or lead? Okay, so the correct answer is iron. Okay. Question number 9. Iron was extracted from its ore in a blast furnace, which uses a very high temp and carbon in the form of fuel coal. Is it coke, monoxide, oxide, or Pepsi? All right, so the correct answer is coke. Okay, so and then coke is burnt to form a gas called carbon monoxide inside the blast furnace.
Teacher, what's
And
the
last question.
plane?
Again, a chemical reaction that breaks down compounds into simpler products. Okay, a chemical reaction that breaks down compounds into simpler products. All right, so the correct answer is decomposition. All right, so that ends our class for today. Okay, congratulations to our top for this Kahoot round. Now, so congratulations to Sylvia, Levana, and Shayona. Now, for those who weren't able to join this challenge so that you can review, or this round so that you can review also, I will be sending this as a challenge. I will be sending the pin for this Kahoot so that you can review as well. Okay. So do you still have any questions about
No.
our lesson this morning? All right. Okay, so if you don't have any other questions, I'll see you next week. Kindly finish the task. We'll have a quiz about this tomorrow. Okay, so again, yes, tomorrow is Friday. I'll be sending the quiz in Edmodo again. And then for those who weren't able to join this Kahoot so that you can review, I will be sending the pin for the challenge, okay? All right. So again,
Okay.
great to see. All right. Okay. So great to see you here, Shayona, Jasmine, Kenny, Levana, and Sylvia. And again, stay curious and have fun learning. All right. If you have any other questions, kindly just message me in Edmodo or in our group chat. Okay. And also your design, kindly continue. I will be checking the progress of your design coding. Okay. So those are just, basic coding activities so that you will be knowledgeable about what programming or what coding is. All right. And if you have questions as well, feel free. Yes, Kenny.
Do we have a group chat in WeChat for the design class?
It's the same. It's the same, science and design. Are you part of? Yes. Okay, it's the same. Science and design class, it's the same. If you don't know the link, I'll be sending the site where you can find all of the links and the classes, Kenny, so that you can catch up with our lessons. All right. So I'll be sending the challenge for review and also the link for our class. Okay. So if you don't have any other questions, again, have a great day and enjoy your lunch. Right? Bye-bye.